the lecture, I just want to remind you about the book, okay? And please, after buying the book, pair that thing with Connect, okay? Pair Connect with the okay? Otherwise later on, if you try to buy the book, maybe it gets delayed and then you will not get it on time, then you cannot do the exam. See, Friday holiday, then Saturday also holiday, so for holidays I don't think so you will not get the books, okay? So even if you pay for reaching it home, it takes 2 to 3 working days. So if you don't buy it in advance, you will be in trouble. We cannot do anything about it. There won't be any makeup quiz. Okay? Everyone heard, right? Okay. So can you see the slide? Can you see the slide?
Yes. Yes.
Okay. Yes. Okay. This I was telling this one yesterday. Molecular orbital. This full lesson is there for the exam. Chapter 9 and 10 full is there for the quiz. Okay. This is the increasing order of energies of molecular orbitals up to nitrogen. That means starting from hydrogen, ending with ending with nitrogen. Okay, and for after nitrogen, that means next element is oxygen. It is oxygen to neon. The configuration is slightly different. See, I told you here, first in this case, pi is coming, then sigma. And here first sigma and then pi is coming. So it's like that. So we are going to fill it in this order, okay? Yeah. Did you get it? See, look, one by one we will do, so it will be okay for you. So first one is H2 molecule. First of all, H2, you know the atomic number of another. See, normally you students make mistakes. Okay, for drawing loose structure, we take valence electrons. But writing molecular orbital configuration, you write the whole atomic number. Don't take the valence electrons. The whole thing will be wrong. Here we use the total number of electrons, not the valence electron. Okay? You heard? Did you hear? Hello?
Yes.
Okay. See, one more point I want to ask you. How was the lab yesterday? Yesterday you had lab, no?
Yes.
Yeah.
The quiz was good?
Yeah, it was easy.
Okay, and then did you understand it properly? See, he showed you the video, no? That with the 3D, with the models. So maybe it is very easy for you now, right? You understood all the shapes, right?
Yes.
Yes.
Okay, so the three-dimensional diagram, that day you asked me how it looks like a trigonal bipyramidal and then tetrahedral. All those structures you understood well?
Not all of us
Yes.
had yesterday.
Not all. No, we did all. All of them were there. X2, X2, X3, X, everything till X6, all were there. Maybe you didn't listen in the lab.
The quiz, the doctor, she mean the quiz, not all of them had it.
Oh, okay, the quiz. Okay, I thought the experiment. Okay, anyway, it's okay. So I don't want to waste time. So now I'm going to do it. You listen. If you have question, you ask. Okay. So now here we have hydrogen atomic number is 1. Okay, so total number of electrons, not valence electrons, total number of electrons. Atomic number of hydrogen is 1, so 1 plus 1, 2 electrons. Okay, so if you have 2 electrons, where will you put those 2 electrons? Someone tell me. If you have 2 electrons, where do you put those 2 electrons? See, here you will fill, in this case, first one. What's the first one? If there are 2 electrons, you will fill those 2 electrons there. Understand? Sigma 1s2. And then if there are 4 electrons, it will be sigma 1s2, sigma star 1s2. Okay? Understood what I'm telling? It got stuck. I don't know. Yes. Okay, fine. Okay. See, dear students, if you have 2 electrons, you put 2 electrons here. 3 electrons here, 2 here, 1 here. 4 means 2, 2. 6 means 2 here, 2 here, 2 here. Understood now? Understood now?
Yes.
Okay, so how do you write? So it is, we have 2 electrons, we will write sigma 1s2. Sigma 1s2. Okay. Now, so we have, see, look here, sigma 1s2. This is the diagram, okay? Molecular orbital diagram, sigma 1s2 we did. And now, sigma star, there is nothing. We have only 2 electrons. Now, there is something called bond order. Did you see bond order? Bond order is equal to Nb minus Na over 2. Look here. Can you see? Bond order is Nb minus Na over 2, where Nb is number of bonding electrons and Na is number of anti-bonding electrons. Okay? If there are unpaired electrons, the molecule is paramagnetic. Unpaired means it's like this. See, this is unpaired. Now, if Camel thing, all orbitals are having paired electrons, it's diamagnetic. So unpaired electrons are present, it's paramagnetic. If all electrons are paired, it's called, come on, tell me, it is called diamagnetic. You studied this thing in 101 also. Okay, so now here, bond order is Nb minus Na over 2. So it is 2, these two, minus 0. There is no electron in antibonding, over 2. So is equal to 1. Do you know the meaning of this? Bond order 1 means there is one bond between atoms. See, there is a bond. If bond order is positive, the molecule is stable. If bond order is 0, that means 0 bond is there. Molecule doesn't exist. So here, since bond order is positive, the molecule is stable. Which molecule is this one? H2 molecule is stable. Okay? Yeah. Now, is there any unpaired electrons? See, look here, common electrons are paired, right? We have only 2 electrons. This is paired, Murphy unpaired electrons. So no unpaired electrons, so the molecule is paramagnetic. Please mute yourself. H2 molecule is diamagnetic. Okay, now next. He2 molecule. See, my dear students, He2 molecule. Atomic number of He. You know the atomic number of helium, it's 2. This is from Jadwal Dowry. So total electrons, how many electrons are there? Tell me. Yes,
2.
total number of electrons. Wahat He2. So 2 He, how many are there?
4.
4 electrons, yes. Is equal to 2 plus 2, 4. If we have 4 electrons, how do you write the configuration? Tell me. You have 4 electrons. So what do? 2 you put here, 2 you put here. Finished. Understood? Did you understand?
Yes.
Doctor, why had 4 electrons?
What?
Why it is 4 electrons?
Because why not 4 electrons? Tell me. Tell my dear. And Wahat He 2 electrons. So we are going for He2 molecule. If you want, I'll write here. I'll remove this. See, 1 He atomic number is 2. So that means Vahat helium has 2 electrons. Helium 2 has how many electrons? 2 plus 2, 4. Now you understood?
Oh, okay, okay.
Okay. So now what's the configuration? Tell me. Sigma 1s2 less than, because it's lowest energy, sigma star 1s2. Bonding has less energy, anti-bonding more energy. So now bond order is equal to Nb minus Na over 2. So how many bonding electrons are here? Tell me.
4.
No. Bonding means without star. Anti-bonding means with star. See, this is bonding electron. This is anti-bonding. Phi star anti-bonding. Ma phi star bonding. Now tell.
2.
2 minus
2.
2 over 2 is equal to 0. So what is the meaning of this? 0 bond. That means between 2 He, 0 bond. That means He2 is not existing. It exists only as He. Phi He, ma phi He2. 0 bond is there. So what you write? What's the conclusion? He2 molecule does not exist. It is not existing. Okay. Instead, it exists only as He. Okay. 0 bond is present.
Victor,
Yes.
from where we said that there are 2 stars or sigma 2 stars.
From where? This is the configuration, my dear. Can you see the configuration on the slide? You didn't come last lecture. You were here in the last lecture.
Yes.
Yeah, see, 2 here, 2 here. This 2 is this one. This 2 is this one. Okay?
Okay.
Understood? Or still you have doubt?
Okay, Victor.
Okay, so now here the diagram. See, sigma 1s2. Can you see sigma 1s2? Now sigma star 1s2. Sigma star 1s2. See? 2 electrons in bonding, 2 electrons in anti-bonding, 2 minus 2 is equal to 0. Okay? Now, see, He2 molecule does not exist. So you don't have to tell it is dia or para. You understand what I meant? Did you understand what I meant? Because the molecule is not there. So no question of telling whether it is dia or para. Huh? Yeah? Okay. Okay. So now next is, after doing a few questions, it is clear for you. Okay. Now, Li2 molecule. Li2. Yes. Come on. Tell me. Li atomic number is, what's the atomic number of lithium from Jadwal Dowry? Tell me. What's the atomic number of lithium? Lithium is 3.
3.
So Li2 has how many electrons? Tell total electrons.
6.
Yes. 2 times 3, or you can write 3 plus 3 is equal to 6 electrons. Now if you have 6 electrons, I wrote, okay. If you have 6 electrons, how do you write the configuration? Tell me.
Sigma 1 is 2.
Sigma 1 is 2 less than
Sigma star 1 is 2.
Sigma star 1 is 2 less than
Sigma 2 is 2.
Sigma 2s2. That's it, finished. See, put 2 here, 2 here, 2 here, finished. Understood? Understood?
Yes.
Okay, so that means sigma 1 is 2, sigma star 1 is 2, sigma 2 is 2. So here we have 2 electrons, here we have 2, here also we have 2. This is the diagram, okay? Yeah? Okay? Is it okay or not okay? Nobody is telling anything. Did you understand here, students?
Yes.
Yes.
Okay. So now
Yes.
tell me the answer. Tell me the answer. Bond order NB minus Na over 2. NB total, how many electrons are there?
4.
4.
4.
Anti-bonding, how many electrons are there?
2.
2. So it's what? 1. So what is the meaning? One bond is there. So Li2 is stable or unstable? Li2 molecule is
Stable.
stable. Okay, next. Is there any unpaired electron? Is there any unpaired electron? Kamil paired. No unpaired electron.
Excuse me, doctor.
Yes, so Li, just a minute, dear. Li2 molecule is diamagnetic. Yes, tell me your question. What's your question?
How's there is no unpaired electrons? What
See
about
here, look here. Look here. This, if it is Vahat electron, if it is there is single electron, it's unpaired. You joined late, I showed you this. On the other slide I showed you, maybe you joined late. This is 2 electrons, means it's paired. Now okay?
Yes.
Okay, yes. Now B2 molecule, what's atomic number of B? B, what's atomic number? 4. So total number of electrons in Be2?
8.
8.
Yes, it's 4 plus 4 or 4 times 2 is equal to 8 electrons. Okay, now tell me the configuration. You just follow here. Just look. You are supposed to fill here, just this one, okay? And fill here. That's it. Fill the middle portion and fill this portion. Yes, tell me. Please tell.
8 electron. Or
So how do you write?
sigma 1 S2.
Sigma 1s.
S2 less than sigma.
Sigma star 1
1s2.
Okay, less than.
Sigma 2 S2.
Less than
2s2.
Sigma star 2 S2.
Okay, that means here 2, here 2. So in this case 2, here it is again 2, everywhere 2. Okay, now tell the bond order.
4.
4.
4 minus
4 over 2.
is equal to 0. What is the meaning? What is the meaning?
Everything.
Yes, Be2 does not exist. Instead, it exists as Be. Understood what I meant? Did you understand?
Yes.
Okay, so what shall I write? Be2 does not exist. It exists as Be, not as Be2. Okay, Mafi Be2, Phi Be. Next, so no need to tell dia or para because it's not existing. Okay, oh, by mistake I wrote all these things. Oh, okay, I forgot to remove it. Just a minute, okay? Yeah. Or shall I keep it like this? Or you want me to write it? My dear students, hello? Shall I keep it like this?
It's okay.
Or you want me to remove it and explain it?
Doctor, explain better.
That's it. So you no need to remove it. Okay, fine. Okay. Yes, I forgot to do it. Usually I empty it and then I explain. Okay. Now look here. I will explain. If you have question, you ask. You know atomic number of carbon is 6. This is from periodic table. We have 2 carbon atoms. So total number of electrons 6 plus 6, 12, or 6 times 2, 12. Now you just fill it here. 2 here. Okay, I will fill there then better. Okay, come on. 6 electrons. How do you do? 2, tell me. 2, here 4, 6. Okay, now it's 8. Now, okay, sorry, there is one I missed. Oh, okay, B2, sorry. Okay, boron, total there are 10 electrons. You understood what I did, okay? So here it is 1s2, 2 sigma star 1s2, sigma 2s2, sigma star 2s2. Total we have how many electrons?
10.
Are you with me? 10.
8.
Okay.
8.
Yeah, so far I finished 8. All of you listen, it's very important. Look, in this case, can you see an equal sign here? Equal sign.
Yes.
So in this case, both of them have same energy. See, look over here. They have same energy. This is in the increasing order of energy. So this is having lowest energy. Energy is increasing. And when it comes to this one, these 2 orbitals are having same energy. So here we apply the rule called Hund's rule. Okay, Hund's rule means if 2 orbitals have same energy, just put Vahat electron here, Vahat electron here. Don't put both the electrons in one orbital. It is wrong since they have same energy. So what do you do? Here you will add 1. Here also you add 1. Did you understand? Did you understand?
No.
Yes.
Okay, my dear. Till now we did 2, 2, 2 because it's less than symbol. So look here, this is having less energy, so you will fill that. Then this one has higher energy, so you put 2, 2, 2, 2. When it comes to this one, these 2 are having same energy. So don't put 2 here, put Vahat 1 here, 1 here. Suppose if they have 3 electrons, say 1 here, 2 here, or 2 here, 1 here, maafi mushkil. If there are 4, you can put 2, 2. Okay, this is which rule? What's the name of this rule? Read it.
Hund's rule.
Hund's rule.
Hund's
Okay.
rule.
Now, this is a configuration. Bond order. See, look, like 2, 4, 6, 8, 10. Bond order is total how many bonding electrons? 2 plus 2, 4 plus 2, 6. Maafi star, so 6. With star we have 2 plus 2, 4. 6 minus 4 over 2 is equal to 1. So B2 is stable, Vahat bond. Now look here, very important point. Here there are 2 unpaired electrons. Can you see? Unpaired. This is paired 2. Paired, here also paired. This much all the electrons are paired. But when it comes to this one, 2 unpaired electrons are there. So B2 molecule S, read it. Read it.
Paramagnetic.
Paramagnetic. Okay. Camel paired electrons, it's called diamagnetic. Now next, C2. When it comes to C2, atomic number of carbon is 6, total number of electrons 12. So how do you do? Tell me. Come on. 2, 4, 6, 8, 10, 12. Okay? Okay? You are not telling anything. Okay. So here we have 2 in this case also. Let me take the laser. So here we have 2 electrons, here 2, here 2, here 2. Camel paired, right?
Yes.
Okay, so it is diamagnetic. Diamagnetic. Okay. Now, how do you find a bond order? So how many without star? 2, 4, 6, 8. Now with star, how many? 2 plus 2?
4.
4. So 2. So that means there is a double bond. So C2 molecule is stable. How many unpaired electrons are there?
0.
0.
0. So the molecule is? Molecule is? What is it?
Diamagnetic.
Diamagnetic.
Diamagnetic. Yes.
Victor, why
Now,
is it diamagnetic?
what?
Why is it diamagnetic?
There is no unpaired electron. If there is, we did all this from the beginning, no? How many questions we did? Look. First one, it's diamagnetic. Why? Why is it diamagnetic in the first case?
There is unpaired electron.
There is no unpaired electron. No unpaired electron, all paired. So it's diamagnetic. Second one is not existing. Now this one. Here, Murphy unpaired electron. See, unpaired, paired is this. Unpaired is this. No unpaired electron. Carmel paired. So it's diamagnetic. Okay, this one doesn't exist. When it comes to this one, see, this is paramagnetic. Why? One Vahat electron. This is paramagnetic. Now this one, there is no unpaired electron. All are paired. So it is diamagnetic. Okay now? Did you understand? Did you understand?
Yes.
Okay, next. Next is nitrogen. What's the atomic number of nitrogen?
7.
7.
7.
Total, how many electrons are there?
14.
14. So now what do you do? Tell me how to do it. 2, 4, 6,
Sigma 1s2.
10, 12, come on, 14. Correct? Correct?
Yes.
Okay.
Yes.
So now here, look, 2, 4, 6, 8. Okay, so here we have 2, 2. Okay, and we have 2 here. So here this is pi 2p. Come on, pi 2p, y2, pi 2p, z2. Okay, bond order. So now, how many bonding electrons are here? How many bonding are here? Tell me. You know bonding means without star. 2. Here 2, 4. Then 6, 8, 10. So anti-bonding with star. So it's 3. So it's like between two nitrogen atoms, there is a triple bond. So it's highly stable. Okay. Okay. So I will write it. Okay. No unpaired electron. Therefore, the molecule is
Diamagnetic.
Diamagnetic. Did you understand all this? Did
Yes.
you understand, or you have question? You have any doubt?
Doctor, I understand everything, but the molecular orbital electronic configuration, I didn't understand it.
That is the basic thing. If you don't understand this, you don't get anything, my dear. Which part of it you didn't understand? Tell me.
How do you even make everyone behind each other? How?
This is the order, my dear. You know, you studied in school 1s2 to electronic configuration. You studied no 1s2, or 2s2, 2p6, 3s2, 3p6.
Yeah.
Studied one order, no. Similarly, this is the order. I'll go back to the first slide. You joined late today.
Maybe 5 minutes.
Yeah, that's right. See,
5.
this I explained last. See, look here. This order you need to memorize. Can you see the order?
Yes.
This is up to hydrogen to nitrogen. This is the order.
Okay.
Understood? Okay. Now, After nitrogen, we use the next order. Can you see oxygen to
Yes.
neon? Okay. Oxygen to neon, you have to do the other one. What's the difference? Tell me the difference. What's the difference?
The blue one is behind, the red one is early.
Yes. Okay. So oxygen, fluorine, neon. This is the order. You need to memorize this order. You just fill. And this one up to nitrogen. This is the order. You just fill.
Okay. Thank you, doctor. Thank you.
Now it's clear for you?
Yes.
Okay. Yeah. Then now. Okay. So okay. Yeah. Look over here. This is the last one under this one, N2. So now we go for O2. What's the speciality of O2? What's the speciality of O2? First, what is coming?
Sigma 2p.
Sigma, then pi. So don't forget in the imtahan, okay? If you make it wrong, the whole thing is wrong. Okay, so be careful. So now here, total oxygen atomic number is 8. Where do you get this 8 from? This 8 is from where?
Periodic table.
Yes, from periodic table. Don't take the valence electrons, okay? Then the whole thing will be some students joined late. That's why I'm telling again. This 8 is the atomic number, not the valence electrons, okay? So now total there are 16 electrons, okay? So who asked me the question just now? Who asked me the question? What is your name, my dear?
Muhammad.
Mohammed, can you tell me the electronic configuration? Just I'm going to fill it here. Tell me the configuration. What do I write here? Sigma 1s2, then?
Sigma star 1 is 2.
Okay, then?
Sigma pi is 2.
No. You just fill it here. Sigma 1s2. After that, what is the next one?
Sigma 2 is 2.
Sigma 2s2. After that? Come on. Come on.
I'm sorry, doctor, I don't remember.
No, you cannot see the slide. Can you see the slide?
The right one?
The top one. The one okay. I am writing. You just fill there.
Sigma star 2s.
Okay, after that?
Sigma 2px.
2. Okay, then?
Pi 2py.
2. You should tell 2. Okay, then?
Pi 2pz.
2. Okay, so now total how many electrons we used already? How many we used? 2 plus 2, 4, 6, 8, 10, 12, 14. Kamil, how many electrons we have?
14 electrons. 16.
16. We used 14. Now we have 2 electrons. How will I write? Tell me. Tell me I have 2 electrons.
16
yes.
minus 14?
16 minus 14 is 2. So how I will write that 2 here? How will I write that 2 here? Tell me.
Where, doctor?
You cannot see the slide.
Pi star 2p, why?
2 pi star. Yes, tell me.
Pi star 2py or the pi star 2pz.
See, these two are having same energy. Can you see the equal sign?
Yes.
Yes, so they have same energy. So you need to put 1 here, 1 here. Understand?
Yes.
Okay, because if they have same energy, you cannot put 2 electrons in pi star 2py. This is wrong. So you have to put 1, 1. Now, okay?
Yes, yes.
Okay, so now here, so the electronic configuration is, see, molecular orbital electronic configuration sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. This one is there. I finished it. Bond order is Nb minus Na by 2. Did you see? Nb, how many electrons are there? 2, 4, 6, 8, 10. I hope everyone can see the slide. Can you see the slide clearly?
Yes.
Okay, so
Yes,
how
yes.
many anti-bonding are there? How many anti-bonding molecular orbitals are there? How many electrons are there? Tell me. Tell please.
6.
Yes, there are 6. With stars, there are 6. 2, 4, 6. So bond order is 2. So that means O2 molecule is stable. But here look, 2, 2, 2, 2, 2. When it comes here, it is 2. Here it is 2. When it comes to here, what's it? Vahat, 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 Vahat electron. Can you see this? Can you see?
Yes, yes.
Okay, so how many unpaired electrons are there? 2. So O2 molecule is, come on, paramagnetic. Is it clear?
Yes.
Is it clear? Okay, next. Next one. You can take the picture of the slides, okay, if you want. After, let me finish it. Now, next is fluorine molecule. Fluorine, yes. Atomic number of fluorine is 9, right?
Yes.
Where do I get this 9 from?
Periodic table.
Periodic table. So Vahat fluorine has 9. We have F22 fluorine atoms, total 18. Okay. Now one of the girls tell me the answer, how to fill it. Tell me. Tell me, please.
Sigma 1 is 2.
Yes.
Sigma star 1 is 2.
Okay. Then.
Sigma 2 is 2. Sigma 2 is 2.
Okay.
Sigma 2. And boy 2b y2.
Okay.
Bat 2.
Okay. Yeah.
2b2.
Star. Okay.
And boy star 2b2.
Okay. Correct now? 2,
Yes.
4, 6, 8, 10, 12, 14, 16, 18. Yes. Okay. Now, so here also look 2. Can you see the diagram? We have 2, 4, 6, 8, 10. Come on. Okay. I hope you understood. So the bond order 10 minus 8 over 2 is equal to 1. Did you understand this, or you want me to show? From where 10? 10 is from where? Without star, yes. 8 is from the orbitals with
star.
So bond order is 10 minus 8 over 2 is 1. So F2 molecule is stable. There are no unpaired electrons. So molecule is
diamagnetic.
And the last one, neon. Atomic number is, come on,
10.
10. Total how many electrons?
20.
So why do you take 20? Why do you take 20? Why do you double it?
Because there is 2 neon.
Because that's
Yes. Okay. 1 neon has 10, so 2 neon has 20. Okay, so now configuration. So come on. Okay, tell me please. So how do you write? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Kamil finished. Sir?
Yes.
Okay,
Yes.
so now here also, can you see sigma 1 is 2, here 2, here in this case 2, here also 2, here 2. Okay, so now Come on. Bonding 10, anti-bonding also 10. So bond order is 0. So what does it mean?
Does not exist.
Says Ne2 does not exist. It exists as
Just
Ne.
Ne.
Ne. Okay. Is it okay?
Okay.
Yes.
Yes.
Sure.
Okay. No.
Excuse me.
Yes, dear. Tell.
What
then
if we want the configuration of a larger molecule?
you need to study only up to Ne2, my dear. Of course, you can. If you are are you a chemistry major student? Are you
Chemical
a
engineer.
chemical engineer? So you don't need it. Okay. Of course, it is there, my dear. It is there. Okay. Yeah. Yeah. Okay. So now, if you have any doubts up to here, you can ask me. Any questions, you please tell. Anybody has any question? Anyone has any doubts?
Doctor,
Yes.
Doctor, if the bound order is negative, what does that mean?
Bond order negative means it's highly unstable. Unstable. Because more energy of the molecule is very high. So it is highly. So usually we will not have normal elements will not have bond order negative. Okay. So if it is there, it's highly unstable.
Okay.
Okay.
Thank you, Doctor.
So now we will go for ionic things. So I will, because it's already done everything. So I will do something, the question here. Okay. Okay. Or shall I, can I make an empty slide? Just a minute. Okay. Can you see this slide? Can you see this?
Yes.
Yes.
Okay. So now, what is written here? Write the molecular orbital configuration of C2 and C2 plus and arrange in the increasing order of bond order, bond strength, bond enthalpy, and bond length. Okay. You listen here. It's very important. I will explain it how to do it. First of all, C2. C2 means total how many electrons are there? Tell me.
12.
Total 12. 6 times 2, 12 electrons. So can you tell me the electronic configuration now? Sigma 1s2. Tell me less than sigma star 1s2. Please tell.
Less
Sigma.
than sigma 2s2.
Okay, less than.
Sigma star 2s2.
Okay, so now how many electrons? Total 8. Okay, now after that.
Pi 2p
Pi 2p
2py2.
Yes, tell me.
Pi 2py2.
Pi 2py2, that's equal to pi 2p z2. What's the bond order?
8 minus 4 over 2.
8 minus 4 over 2 is equal to 2. Correct? Okay?
Yes.
Okay. So now C2 plus. C2 plus means it's a cation having one shortage of one electron. It's there one electron less. So what can I write? 12 minus 1 is equal to 11 electrons. Did you understand? Did you
Doctor,
understand? Yes, tell.
why we don't put Y2BX2?
No, it is the X is last lecture you didn't come. X is in the internuclear axis. It forms sigma bond.
Okay.
X, the one in the internuclear axis always forms sigma. This I explained last class. No, the one in one perpendicular to it will form pi bond. Y and Z form pi bond. X will form sigma bond because we consider X axis as the internuclear axis. Okay. Yes. Tell me now. You understand why I wrote 11?
Yeah.
Yes,
No.
because there is a
And
positive.
yes. So this is same. If I don't write, is it okay? If I write like this, is it clear? Or you want me to write it?
It's clear.
Okay. So here, what do you get last? Now you have 2, 4, 6, 8. Now we have 3 electrons. So what can you write? Pi.
I2 PY2.
Okay. Pi 2py2. That's equal to pi 2pz1. Okay, correct? Or you can write
Yes.
first one, second one, 2. So what's the bond order now? What's the bond order?
It's 4/2.
How much?
7 minus 4/2.
7 minus 4/2 is equal to 1.5, right? Correct?
Yes.
Correct. So, okay. Now I'll just go back to the previous slide. Can you see? Can you see this slide?
Yes.
What is written there? Bond order is directly proportional to stability. That means if bond order is high, stability is high. Understand what I meant? That is, if bond order is high, stability is high. Or bond order is low, stability is low. Then, bond order is directly proportional to bond enthalpy. Bond enthalpy means the energy needed to break the bond. Okay? Energy needed to break a bond. So, if bond order is high, bond enthalpy is high. I write bond enthalpy like this: bond enthalpy is high. Okay. Bond order is inversely proportional. Inversely proportional means if bond order is high, come on, tell me, bond length is
Short.
yes.
Short.
Yes, short, less. Okay. Now, if bond order is 0, molecule doesn't exist. This you know. Okay. Now, come on, tell me. Yes, so you have to write in the increasing order. What do you mean by increasing order? Small to big, okay? Less to small to big value or less to more value. So now A, bond order. Okay, what is the order? Which one has less bond order?
Plus.
Come on. C
C2 plus.
plus, then C2. B, bond strength. Come on, tell.
C2 plus.
Yes, it is same. C2 plus C2. Bond enthalpy.
C2.
C2 plus and then less than C2.
Also the same. Then bond length.
C2 less than C2 plus.
Yes. This is opposite. C2 less than C2 plus. It's opposite. Yes, different. Okay. Now, so what does it mean? Which one is longer bond? Which is longer bond? Longer bond is?
C2 plus.
Yes. C2 plus has longer bond. C2 has shorter bond, right? Okay. What about paramagnetic or diamagnetic? Which is para, which is dia? Which one is paramagnetic? Which one is diamagnetic?
C2 plus is paramagnetic, C2 is diamagnetic.
C2 plus is paramagnetic. C2 is diamagnetic. Okay, it's clear. Now it's okay for you?
Can you repeat?
Yes, dear, tell.
Can you repeat
Which part?
this part?
Dia and para?
No. Bond order, bond.
See, just now I told you, my dear, if bond order high, stability high. If see, just go for the order of the bond order. If see, this one has high bond order, so it has high bond strength. So it has high bond enthalpy. These three are in the same order. If bond order is high, bond strength is high, bond enthalpy is high, bond length is less. Bond length the opposite way. See, first one's bond order C2 plus, I will write the bond order. See, C2 plus bond order is 1.5. 1.5. This is 2. Based on this, I wrote all this. Understood now? Understood now? Or still you want me to still explain more? See, this one has number is 2. This is from here I am writing. 1.5 is this 1.5. This 2 is this one. Right? So if bond order high, bond strength high, bond enthalpy high, bond length low. Okay, so this is this bond length is high. Bond length high means long bond. You understand the meaning of bond, right? See, longer bond means it's like this long. Shorter bond means short. Now understand long and short. Okay.
Yes.
Okay. Now there's time to do. We have one more question to do that we will do next lecture. Okay. I hope everyone understood everything, and I just want to remind you about the book. Okay, please buy the book. Those who have book from 101, you just pair it with the blackboard in my section. Your section, no, section 7 or 8 or 9 or whatever, you just pair. And those who don't have the book, buy as soon as possible. Your quiz is on Saturday. If you miss the quiz, there is no makeup quiz. You will lose marks. Okay, and it's an easy quiz. Easily you can get full mark from the quiz. So,
Doctor,
yeah, tell please.
what are the chapters that are in the quiz?
Up to chapter 9 and 10. I told you, no, chapter 9 and 10 are included in the quiz. 9, 10 means up to this one, this slide and one more slide I have to do, that I will do next class. Okay, after that we finish. I almost finished. I just want to give one example more. See, there are 90 students in my class. Only 71 students attended the lecture. So that also is an issue. Every day I'm taking the attendance. I have the record of full attendance. Okay. And if you don't come for the lecture and you don't know what's going on here, and if there is some people are telling, we don't know about the quiz. Quiz is from there. About the quiz, I send it in the, what is it called? Our syllabus. I send the syllabus. Syllabus, it's there, and every lecture I'm telling you have quiz on Saturday. So if you miss the lecture, you won't be able to know all these things. So it's your responsibility. If you miss the quiz, there is no makeup quiz, so make sure you attend the quiz. Okay, and make sure you attend all the labs. If you are absent in the lab, you get 0 for that lab report. So that also is very important. Okay, dears. Anything else to ask?
Excuse me.